In example 2, we're looking to continue the hypothesis testing for a population mean. So in example 2, each bar of fun-sized Snickers in a bag is supposed to weigh an average of 20 grams to avoid false advertisement. So the manufacturer calibrates their machines, so the mean weight is 20.1. The manager is concerned that the weight is below manufacturer standard, so a random sample of 11 candy bars are weighed and recorded, and we have a data set here. Should the machines be recalibrated, test whether the mean weight is below 20.1 grams at alpha equals 0.01, level of significance. Okay, so we'll proceed very similar to what we did with example 1. First step is to set up the null and the alternative hypothesis. Okay, so with each hypothesis, we do have to gather the parameter of interest. Once again, that'll either be proportion, mean, or standard deviation for the population. Okay, so in this problem, the only parameter that's mentioned is the mean. Okay, so it's safe to use mu as a parameter. Once again, in this class, the null hypothesis will set up as an equal sign. And then for the alternative, we're looking to identify the alternative symbol in the problem, the key word for the alternative sign. And in this problem, here towards the end, also towards the middle, okay, here the manager is concerned that the weight is below. Also towards the end, we're asked to test whether the mean weight is below. So the word below, that's associated with less than. Okay, so here it's safe to use the less than symbol for the alternative. And we're looking to identify the population value in the problem. So it states it a couple of times in the problem here, also towards the end, that we want to be below, test whether the mean weight is below 20.1. So we'll use 20.1 for both values in the hypotheses. Okay. So here for step 2, we're going to gather evidence to see whether or not we reject the null hypothesis. And just like before, we're going to use the p-value method. We will compare p-value to alpha. Okay, we'll compare the p-value to alpha to determine whether or not we have strong or weak evidence against the null. So the setup, whenever we're testing for a population mean, that's going to be t-test. Similar as before, right? In the previous video, t-test. But there is a significant difference with this problem from the previous example, right? So when we go to stat test and then t-test, okay, the input. So in example 1, the problem actually gave us enough information to plug in when the input was on stats, right? We were able to input x bar, s, and sample size. In this problem, we're not actually given x bar and s, but we are given a data set. So what we need to do, eventually we're going to go to the input data, where the input data will ask for the hypothesis value in step 1. Notice that we use 20.1. Let's go ahead and change that. But then it's asking for lists. Then it's asking for a list. What it's asking for is the data that's in the problem. So before we can use t-test, I'm going to second mode to quit to the home screen. We actually have to enter the data into L1. So stat, edit. Let's go ahead and enter the values into L1. Here I've already entered these values, but be sure that all values are entered into L1. Okay. Once you do that, it's always safe to quit to the home screen, just so the calculator doesn't get confused when we run the t-test. So now, let's go back to stat, test, and t-test. So we've entered the population value, 20.1. The calculator is asking where is our data set located. Now, if you enter your data set into, for example, L3 or L4, then you can hit second 4 on the keypad to make sure that the t-test has the correct data. Okay. Here for us, we enter the data to L1, so here we'll change it back to L1. Now, frequency, I want you to leave that by default as 1. Okay. And then for the next line, we're going to gather the alternative sign. So for the alternative sign, here we were asked to test if we're below. And once again, we're looking to match that symbol with the calculator. That symbol will be this middle one right here. So imagine taking this middle symbol, the below, and just shifting it over into the calculator so it matches that symbol exactly. Okay. And let's see, let's gather our evidence. Let's gather the evidence. Once again, 3 ways to gather evidence in statistics. We're using the p-value method for a more practical use, but MyMathLab will ask for something that we call the test statistic. Once again, in a separate video, I'll show you how to use this test statistic. It's a more difficult way to gather evidence, but a nice way nonetheless. Go ahead and give MyMathLab the value of the test statistic, and once again, give it the value as is. If it's a positive, go ahead and enter it as a positive. If it's a negative, go ahead and enter it as a negative. And once again, it should actually be T naught. Calculator represents it as T, but it should be T naught. Here, regardless, p-value is evidence of interest, and we compare to alpha. So alpha, okay, we're given 0.01 room to make a mistake in our conclusion. After conducting our test is saying, hold on, you have about a 0.83, let's call it 0.84 chance of making a mistake in your conclusion. So let's think about whether or not that's a good thing. So we're given 0.01 room to make a mistake in our conclusion. After conducting the test in the calculator, it's telling us that we have about a 0.84 chance of making a mistake in our conclusion. We are not below the threshold, okay? And if you are not below the threshold, that is considered weak evidence against the null. And if you have weak evidence against the null, do not reject it. Do not reject the null hypothesis. Okay. So now we're ready to conclude. Conclusion. Do not reject the null hypothesis. At alpha equals 0.01 level of significance, we do not have enough evidence. To conclude that, and here we're going to repeat the alternative hypothesis, that the mean weight is below,